Hello, this is Miguel Cardona, Secretary of Education. I'm glad to be with you today at CareerConn. When I was a student in Connecticut, I explored different pathways to see what I'd be interested in, and all of that helped prepare me for my career in education. And I know you've had an opportunity to explore different careers. Regardless of what you choose something you love, take a risk. I know that if you do, you will contribute to a better Connecticut and a better country. Good luck to you. Enjoy the conference, and I hope to see you soon.
Hi, my name is Kate Erico, and I'm here from District Arts and Education.
And I'm Atakakra Ditome, otherwise known as K, and I'm the software engineer and head of education at District Arts and Education.
And we're here today to talk to you about the computer science career track. And we're going to do this interview style. So the both of us are going to be kind of just talking to one another about what this career path really means. So Kay, what careers are in the computer science track?
Yeah, so there are several in this space, and I'm going to talk about the main ones. So starting off, I want to talk about you can be a software developer. Basically, what software developers do are basically use principles to develop software solutions that satisfies the needs of businesses and consumers. And these include solutions on desktop, web applications, mobile applications, games, robots, operating systems, network systems. And then we have a software engineer. So a software engineer basically does the same thing, but a software engineer's question is always, how can I make this better? How can I make this efficient? How can I make this fast? Is it using too much memory? Is it taking too much time? Is it using too many resources? So the software developer's role is very direct. This is a problem. Create an app that solves this problem. And then the software engineer is, okay, how can I go in there, tweak this solution and make it better? And then we have a data scientist. So that's data science in general. And so data scientists use algorithms to extract insights or knowledge from data. Whether it's organized data or not organized data. So that's another field as well. And then we have web development. So you can be a web developer. And basically web developers design and build websites. They're responsible for the look of the website as well as the efficiency of the website. And also making sure that it's accessible to everyone. So building websites, that is accessible to people who are blind, people who can't hear, people who can even see. And every organization or even entity needs some kind of web presence. Okay, so moving on, we have a full stack developer. Now, before I talk about who a full stack developer is or getting into full stack development, there are different pieces to this. There is a front end developer, and a front end developer basically builds applications and they focus on what people see, basically the front end side of it. And we also have a back end developer. A back end developer builds the back end internals of the system. So it's similar to like a vehicle. So the person who works on the interior side of the vehicle, which is like the engine, the internal, and then the exterior side is just basically how it looks. So that's the difference between a front end developer and a back end developer. Now, coming back to a full stack developer, that's kind of like a hybrid. This person works on all of them, front end, back end, and even other pieces to it when it comes to the network side of things, and something called development operations. So that person does all. And then you can get into network architecture. So you can become a network architect. And these people basically work on network architecture design, and they build data communication networks, including local area networks, LANs, and wide area networks, intranets, things like that. You can also go into software testing. So you can become a software tester, and your job is basically making sure the software is of quality, and also help deploy that software so it's live for people to use it. So they work on manual and automatic tests to make sure the software works as intended. And then you can also go into system analysis, so you can become a systems analyst. And basically, systems analysts analyze how well software, hardware, and the wider IT system fits in a business, so they can better tell the systems that are needed to make this business work well. And they use computer technology effectively and efficiently to make sure that a company is doing what it's supposed to do very well. You can also become a database administrator. Database administrators, they use software to basically store and organize data, and that includes the design of the entire system, and making sure that they plan capacity. Also making sure they're able to install that database in different applications, configuring it, making sure that they can migrate it from one system to another, making sure that they're monitoring the performance of it, making sure it's secure, troubleshooting it in case there are issues, and then being able to back up and being able to recover data in case there's data loss. So that's what database administrators do. And then, of course, I think lots of people forget about this, but you can also become a computer science professor and teach these principles. And I think that's a great place to be. I admire my professors a lot. I've learned so much from them. So that's another career on its own. There are a few important ones I want to mention before we move on. Okay, so bear with me here. You can become a mobile applications designer or developer. So the difference between that is the designer is more focused on the less technical part of it, just designing and wireframing the application, and then the developer focuses more on the technical parts of it. And you can also become a computer scientist or computer science researcher. So computer scientists basically invent and design new approaches to computer technology, and also find innovative uses and ways to make sure they're using the existing technology even better or beyond its capability. And then going into artificial intelligence and machine learning, they work hand in hand. So an AI or artificial intelligence engineer builds AI models using what are called like machine learning algorithms and what are called deep learning neural networks. I know these are very technical, but they use these things to draw business insight and knowledge, and which helps businesses make some really important decisions that affect their entire organization. And then we go into AR, VR, developers or engineers. That's augmented reality and virtual reality. Developers or engineers, and they basically create simulated worlds, immersive virtual reality spaces for training, educative purposes that run on different platforms, mobile, desktop, VR headsets, phones, computers, to basically teach people, have them experience different worlds and different scenarios without necessarily having to to be there or having whatever it is in hand. So these are a few careers in this space. I think these are the main ones, but there's certainly lots more.
So there's only a few things you can do in computer science, is what I heard there. It sounds like there's a lot. So what kind of educational requirements would there be for all of these careers, right? It seems like there's a lot you can do. What do you need to know in order to enter into some of these career fields?
So depending on the type of organization you're interested in working for, and even the role that you're going for, the educational requirements can range from professional certificate to all the way to degrees. One thing that I want to say is that, and this is important, I think that organizations are dropping the requirement of having a traditional college degree. What employers are leaning towards is basically they want to see hands-on experience. They want to see portfolios. Have you built personal project? Do you showcase your true passion? Do you understand the technology? And can you create solutions using those technologies? So it's important, these to have these certificates and degrees. That's what's needed, but companies are kind of dropping that. So I don't know if
Yeah. And do you feel that like here in Connecticut that is you're seeing more of that for organizations?
Yeah, this is actually a worldwide thing. I'm seeing that worldwide. Even Google just announced that they're going to come up with a 6-month program. They don't necessarily require a college degree to work there. I'm seeing that more and more, even in Connecticut.
Why do you think that is?
I guess they've realized that a degree isn't, they realize that a degree doesn't necessarily, show or mean that, you're able to create these solutions or understand it. They have seen lots of competent engineers, not necessarily having these degrees, who are able to create these solutions and understand these problems and create solutions around them without necessarily having the degree.
Yeah.
I guess it's based on research, based on just seeing all these employees come in, having this requirement and not seeing a lot of progress around it, right?
Right. Awesome. And so can you explain a little bit more like about the educational programs in this kind of a track? So you mentioned degrees, right? Obviously going to like a 4-year university, but what else is there?
So it's important to have a computer science degree, like a traditional computer science degree, and even a master's program, because they cut across. They teach you a lot about lots of these careers, and you can easily jump into these careers and work with these degrees. So they're important. But more and more, we're seeing very intensive, shorter term and training programs like boot camps and certificate programs that give you professional licenses. Very intensive, very focused on just the technology without anything around it. We're seeing more and more of that.
Yeah.
Yeah.
Cool. And are there any sort of licensure requirements that you need to enter into a computer science career?
Yes. So depending on the area you're going to, for example, if you're going into networking, there are some very popular certificates and licenses you need to get. If you are going into more programming, there are specific programming language certifications. If it's Python, whatever it is, Python, PHP, there are specific certifications you have to pass that that help you get into the space. So those are important, but I think what's more important is just just the passion to continue learning. Computer languages come and go, and so just staying active, learning new programming languages, keeping up with the pace of it helps you to be able to jump into these languages, get up to speed, and get through these certifications. I think that's what's more important than trying to get these licenses as much as they're important.
Great.
Yeah.
And I think the question that we're all kind of wondering, of course, is, what is potential earning really mean in a computer science degree program? What are salaries like? What does that look like?
Yeah, that of course, that's an important question. And software engineers and people, folks in technology, get paid a lot regardless, right? But the national average salary for a software engineer, as an example, right now is around $92,000 according to Glassdoor. And factors like organization size and seniority level, location, things like that can impact whether your salary is higher or lower, than the national average. So that's up.
Do you think that in terms of computer science, like what is the type of organization that would really need people in these fields?
I think every organization, like a lot of people think that companies like Google only do these things, but every organization needs some kind of technological solution. And so you really don't have, like, you're not out of options in terms of like places to work for. And I think that's something that lots of people underestimate.
Yeah.
Yeah.
Great. So what I'm picturing, we're computer scientists, right? Or we're working in this field, this very broad field. I'm picturing someone who kind of goes into the office every day, sits down at a computer, and just sort of like does some of this. Is that true? And what does it look like? What's a typical day for someone who's in one of these careers?
Yeah. So with lots of traditional jobs or careers, you go into the office, you sit down, you get your stuff done. It's 5 o'clock, you're out. And of course, as an engineer or someone in technology, you're going to be spending time, working on your craft and independently. But most importantly, you're going to be spending more time as an organization trying to understand what problems you're trying to solve. And so what that means is you're going to be having multiple meetings trying to break down the problem, right? So I always say that understanding the problem is part of the solution. And so there'll be countless meetings looking at high level, breaking it down, what the problem is, trying to understand the internals of it, what's required to get it done, what team or what pieces need to be solved by what team. Like you break it down, you kind of pushing it out to different teams, and this is not a one-day thing, right? It could take weeks, could take months, could take years. You constantly spend time whiteboarding, visualizing the different pieces, trying to have a solution before you even break out to work on your individual roles. And this isn't, again, a one-time thing. You have these meetings, go work on it, come back, re-review, high level, lots of whiteboarding. That's what I do. That's what lots of engineers do, lots of people in technology do.
So what I'm hearing there is that every day looks a little bit different than the other, right? So you're not really going into a hovel and hacking your way into, okay, great. That's awesome.
And you see more of the meetings to kind of dissect the problem than just being in your office, just coding away.
Right. So you really work with a full team when you're really in the field. That's great. I think one of the questions that everyone sort of has when it comes to this computer science for someone who maybe doesn't have a great science background, math background, not a ton of experience in this field, computer science may feel really far away. Is this something what type of person can be engaged in one of these career tracks?
So that's a very good question, because that's something that's very important to me. There's this misconception that this space is for a certain group of people, but no, every single person, anyone can do it, and you don't need to be someone who got straight A's in school, or someone who's extremely smart, right? Whatever smart means, to do it. All that's required to get into the space is the passion, the commitment to just want to do it, want to give it a shot, and the ability to stick to it when it gets a little bit challenging. In life, everything is challenging. So it's just the person who wants to give it a shot and is willing to stick to it, accepting the fact that this is going to be a bit challenging, and just stick to it. This is the kind of person who's going to do well in the space, just like so many other things.
Awesome. And for you, Kay, what do you love about computer science?
I think that it's, without technology, our lives would be much harder. It's just lots of problems is just going to be, it's helped us in so many ways. It controls everything we do, from what we eat to how we move around to just how we work. Every single thing is controlled by it. So for something that's taking care of us, and for something that's allowing us to also express ourselves in solutions that help other people in this world we live in, I think it's great. The fact that we're all at the end of the technology in a positive way, it's great. It's just awesome.
Great.
Yeah.
And can you give me an example of some type of experience that you've had as a software engineer, or someone that you know, like within our network, what are some experiences that you've been able to have because of computer science and this career track?
Yeah. So the question is kind of broad, so I'm not sure exactly, and I'm going to try to answer it. So experiences, I think that, beyond all the technical stuff we've talked about, I think it really empowers people. I think that computer science and technology in general is just an extension of our ideas and what we're thinking inside. There's so much we can do with our ideas, and technology just helps us be able to extend these things, and bring it to reality that helps other people in ways that we cannot imagine. And that can be really empowering. That can push us to continue just doing more beyond whatever we thought. And I think that's a really positive thing. That's the experience I've seen in myself and in people, and that's really nice to see. It's just a good thing, a positive thing. So I guess I could speak to more of this, but that's the experiences I've seen are basically around that.
Awesome.
Yeah.
Well, great. I really appreciate you taking the time to talk to all of us about computer science, about this career track. Is there anything else that you want to add?
Oh yeah, and I think I mentioned it. If you are interested in this space, but what's holding you back is the fact that you think that this is not for you because it's for this group of people or that group of people, or I can't do it. It's just too difficult. I want to tell you that it's not so. All those things are false, and they're just misconceptions. If it's something you really want to go for it or give it a shot, do it. You don't know something unless you try, and you'll be surprised what you can do. You're all very capable of amazing things. Give it a shot. It's going to be tough, just like everything else, and it's a fun kind of tough. Embrace it, just like everything else, and stick to it. There's lots of help for you. There's a huge developer community, huge engineering community, and you get the help you need as long as you just stick to it a little bit more. That's it.
Awesome.
Yeah.
Well, thank you so much, Kate, for joining us. We look forward to answering all of your questions after this, and we hope that you enjoy the fair.
So, hey, everybody, I'm here to talk to you today about careers in information technology, computers, coding, and just all the opportunities that are out there and how you can take advantage of them. By way of an introduction, my name is Jeff Auker. I'm the head of innovation and delivery here in Hartford for a big company called Infosys, which spans the globe, works in about 80 different countries for all of the biggest companies in the world, doing a wide range of things from maintaining their laptops to, putting some of the most sophisticated technology in, all sorts of different things. So I wanted to talk to you a little bit today about the ways into a career in information technology. It's a really exciting field these days, and it is something that I can guarantee you we simply can't get enough of at all levels. And there's a lot of great ways to get into IT, and kind of break it down into a few different buckets. One of the best ways to learn how to get into the field and progress is really by managing the stuff, whether it be the laptops, the networks, the databases. And there's a lot of great ways to learn about that. And as you learn how to manage this stuff, then you get to learn how to do things to it, to fix things, especially with network today. So networks, everything is connecting the computers. A really hot way to get into information technology is to learn how they work and help monitor them for performance and make sure that they're up and running and all that. And then you progress into maybe fixing the things that go wrong. But that also leads into a great understanding of how these networks work in ways that you can help work in probably the hottest area in information technology, which is cybersecurity. So you're the one that's detecting threats and fixing them and alerting people to them. And that's such a clear path up through on the network side. Similarly with databases. So this is where we store all the information about people, products, TV shows, everything out there. And as you learn to manage the databases, everything in IT runs on data. And the more you know and the more you can do with that stuff, that can eventually lead into exciting careers in artificial intelligence, cloud, some of the stuff way up there. And there's some very clear ways to start to get into that and move on up. Another area that's incredibly important is, people have to understand what people are trying to do with the computers, the iPhones, the Androids, and all the different things you do with code. So we need people that can go out and understand what users are trying to do. They're called analysts, typically business analysts. And they have counterparts called project managers and program managers for the big projects. And you need people that can basically be the glue between either the business folks, the people that want to use an app on a phone, and the coders, and basically translate from one to the other. And there's great ways to come in and get to know certain industries, certain types of code out there, and be the ones that really translate between the humans and the folks building the stuff. And another really hot area, and I'll talk a little bit about this more, how to get into it right now, is always around web and app development. And there's so many different levels of what you can do there. And some of these things get really complex, but a lot of them have some really basic components that you can learn on. And so if you look at kind of managing the stuff, writing code for the web or for apps, working on the analysis and managing the programs, there's a lot of ways to get in, and they all have nice clear ways to get there. Education required. I want to kind of dispel a myth. Typically, it had always said you need a 4-year degree, maybe a 4-year degree plus some experience to get into some of these jobs. And that really is breaking down right now because, like I'm saying, there's so many different paths in, and we're in such short supply in the IT industry of folks. We are consciously, especially here in Connecticut, looking for ways to guide folks, whether with a high school degree, a community college degree, into certain certifications, certain training, apprenticeships, internships, ways that we can start to build a bigger and bigger force. So you will increasingly see, and this is something we can talk about, different ways to get into technology without that typical 4-year degree. And our company, our industry, our state depends on making sure that those things work. What you do need, though, is somehow to get a basic understanding of how technology works. And there are obviously programs in schools which can give you the 101, 201, 301 stuff. There's some great certificate programs out there, some associated with schools, some not, in very specific tools that can help you build things or manage data or manage networks. And when you get into these programs, to be very specific about what that qualifies you for. But what's very cool about technology is what you really need in the end is real world experience, whether it be an internship, whether it be a project associated with a class. Any certification will have you go hands-on to actually do some work, and that's basically what they're certifying, is that you have the ability to do it because you did something. But what's most interesting about technology, especially as you get into things like apps and web development and all that, you can just pick up a book, learn the stuff, and develop a portfolio. So many people are getting into technology by just coming in and saying, hey, I built this. Look at what's on my phone. I did this. You'll see people on YouTube putting up demonstrations of what they've done. So the hands-on piece, I think, is most important, and in many cases more important than a degree. So think about that. If there's something you're really interested in, what could you do on your own? What could you walk into somebody who could offer you a job and say, look at what I did. That's incredibly powerful these days. In terms of what you can make in this field, on one hand, the sky's the limit. I mean, literally, the sky is the limit. But typically an entry-level position with a college degree, a 4-year degree will be around, I would say, $60,000 to $75,000, depending on what you're doing. A community college degree, we've been seeing $40,000 to $50,000, and there will depend on the kind of certificates you have. And even folks without even an associate degree with certifications, there's definitely ways in the $35,000, $45,000 up to $50,000 range. But again, it's going to be that experience you've shown, the certifications you have, and ideally something you can walk in and show them that they did. In terms of what you'll be doing, it's such a wide range of things you can do in IT. But I think the key to it is every day it's more and more collaborative. these systems are so complex that you need different people looking at it from different angles. And especially the people that sit in the middle, that glue, those analysts and project managers, they're the ones running around talking to everybody, getting the different requirements, getting the different perspectives. And we have to work in smaller teams. These days it's been very virtual, but the way it's set up, you will be part of a team. You will get to see things from different perspectives. And one of the things I love in our office is, when we're there, people are getting together at lunchtime. People are learning from each other. People are like, hey, I'm really having a problem on this one web application I'm building. Who's worked on this tool? This called Spring or Angular. Help me with my problem. In the office behind me, at least virtually, we got whiteboards up everywhere. We've got these touch screens that people are bringing up and working in groups on. And that's the piece that is most exciting, because if we're going to make these, this technology work for humans and bring great experiences, you really have to work together, and you really have to understand the people on the other side. So that's what makes it exciting for me. So if this interests you, please stop by our virtual booth, look at other folks that are talking about all sorts of technology. In manufacturing and healthcare, technology is becoming increasingly important every day. So stop by, ask us some questions, and best of luck to everybody.